My name is Michael Meadows. I am a programmer for a company called PriorAuth Now, based in Columbus. So if any of you are looking for a really cool company to work for, come talk to me after this. A little bit about myself. I actually do back-end programming, not UI programming. But I got really interested in this idea, this event-driven user experience pattern, when I discovered that sockets existed. And I kind of just, toyed around with it over the years, but really came across when Angular 2 came out. It came into this, sort of understanding, especially with the reactive extensions, which I'll show you guys in a little bit. That we've kind of reached the sweet spot for this. And so I decided to put together this talk to help other people understand at least what the potential is and how we can kind of rethink how we design websites, especially websites that are workflow-based websites. So not necessarily single-page, apps that are more about displaying data, but apps that are more about creating interactive user experiences. So I put this together and kind of focused on anti-patterns, things that we do today because of the request response world, and present some patterns, which are, well, if we weren't bound by this whole request response paradigm, what would we do, right? And I'll give this link here at the end of the slides as well, so that you can go find both the slide deck and the code. All right, I promise you this is like the most words that you're going to see in the whole presentation here. Here's the problem. When I started looking into Socket.io or SignalR or any, oh, I can't do that. All right, sorry, I draw my interactive wall right here. When I started looking into socket frameworks, I ran into this problem, which is if you go to any one of the socket frameworks and you look for example code, what you end up with is either chat or games, right? Well, that doesn't really help me because I want to build business apps, right? So if I drew you here because I said you're going to have real world examples, I hope you feel fulfilled at the end because that is my goal here. So I'm going to bore you, but I promise that we'll get to code and some examples here in a little bit. I just want to make sure that from a foundational perspective, we've got a baseline here. So why Angular? And it was 2, now it's 5.2. I'm a little less confused now, but I still don't know how to search for Angular on the internet because it keeps pulling back Angular 1. And I don't want to get drawn into a holy war conversation about, well, you should have used React.js. I like Angular, right? And I don't have a problem with TypeScript. And I really like the fact that the reactive extensions work really well with TypeScript. And that's really going to help when we get into the data-driven code. So, primarily, it's actively being developed on. It's pretty well documented, and the CLI for Angular makes it really easy to do some things. So why event-driven server code? I talked a little bit about this, but I really feel that we end up doing a lot of work that is because of the technology limitations of request response. We do have Ajax, but well, okay, show of hands, who likes Ajax? Yeah, you like Ajax programming? It really sucks. And one of the reasons that it sucks is that we're trying to do asynchronous, we're trying to make your web page look asynchronous using an asynchronous framework that behaves like or using an asynchronous protocol that behaves like a synchronous protocol. If you want to actually decouple your request from your response, you're going to have a lot of problems getting that to actually happen. When we use sockets, we actually create connections directly between the server and the client. And when we do that, we get better security because we only have to send what we need to send, and it goes directly to the client. That opens us up to the opportunities to be more responsive in how we build our user experiences. You'll see some of this. So Socket.io. So I'm a .NET programmer, and when I first started looking into this, I was using SignalR. Now, one of the problems with the socket libraries is that there's not a lot of problems to solve. So once you've built, sort of the library, minor bug fixes, the project dies, right? Because it's really a small problem that you build a little bit of framework around. Socket.io is still somewhat in development, so I kind of moved that way, and I wanted to try a Node project anyways. All right, so let's talk about the patterns and anti-patterns. And I'm going to start with the anti-patterns. What are the things that we do that I think are stupid because we live in a world where request responses is our first choice on how to transmit data and get data from servers? Well, request response, right? If you've ever had to build a system where you're bound to some reporting service and it takes forever, I will say this. 2 seconds is a very, very long time. Not only that, but you can't really predict. You can't reliably say that this report is going to take X amount of time to come back if it's based on filter criteria, right? If somebody just says, well, just give me everything, it may take 10 times as long as if they say, give me this one thing. Users don't necessarily want to have to wait for a report to complete. They just want to be able to say, do it, and then I trust that it's going to come back. It may be a little unnerving for them at first, but they get used to it. If any of you work in Azure, they do this well, right? So if you go do something in Azure, it could take hours. And it simply says, okay, well, when it's done, I'm going to notify you, and you can click and then continue if you want. Polling. So I'm going to imagine that all of you didn't raise your hand when I asked if you liked Ajax, because you probably had to at some point implement polling, right? So, well, I want to know when something changes. When somebody adds something to this list, I want you to put it on. And that gets even worse, because then you're like, well, but what if you're editing something on the list, right? Polling also can just crush your server, right? So how often do you want it updated? Every 10 seconds? Every minute? If you have 1 million users, that's 1 million extra requests a minute, right? And if nothing changes during that time, you're still fulfilling those requests. And it gets complicated on the other end, on the client side. Well, what do you do if something is updated, right? So you end up having to implement something in 2 different ways. Once if you're displaying it for the first time, and then the second time if you're polling, right? Polling sucks. I've had to do this. If I had a dime for every time I had to implement polling and regretted it, I'd have almost $1. The save button. This one's a little controversial, but I'm going to insist that we do need the save button sometimes, but we almost never actually need the save button. The save button is a pattern that we have implemented or submit, right? Because we, in the Web 1.0 world, we needed to sort of collect all that data on a form, and then when they send it, what used to happen is it got written to a file on the server, right? And then somebody would do something with that file. But that's what happened when you posted something. It was actually creating files, and for some reason we've held on to this pattern when we don't really need to, right? And sockets really enable us to get rid of this, and you'll see that in the example. I don't have a save button. There's some other interesting things that we can do when we get rid of the save button as well. And the save button itself is going to create another anti-pattern, and I don't know if that's the one I get to next. Yeah, optimistic currency. So if I had a dime for every time I've had a frustrating conversation about optimistic and currency, I'd also have almost $1, right? And I'm going to make a complete fool of myself because I'm going to do a little role-playing right here. And this is, I mean, I don't look like that, but this is me in these conversations, right? Where you go up to the client and you're like, hey, I did just walk in the light, but I got to be over here, right? So we need to know what kind of concurrency model you want. And the client's like, okay, yeah, cool. Well, what does that mean, right? Oh, pay attention to the emotions here. Well, so you can have optimistic concurrency or pessimistic concurrency. Oops, sorry. Yeah, well, just give me the best one. I think you should get optimistic concurrency. What that means is that if two people open it, the first one that saves wins. The second one has to start over, right? Oh, yeah. Oh, wait. No. What? No. Why would I want that? Right? That doesn't make any sense. How about if when the first person opens it, it doesn't let the second person open it so that they don't have to start over, right? Well, yeah. That's pessimistic concurrency. Sorry, I'm getting my exercise right here. Yeah, that's the one I want. Give me that. Yeah, and then here's where it turns, right? Watch this guy's emotions switch, right? Well, that's not how the web works. Users don't give, I don't know if I should curse. Users don't care that that's not how the web works, right? Optimistic concurrency is anathema to them. There's no, I like that. There are not very many foreseeable scenarios where a user actually wants optimistic concurrency. It's not how they work in the real world, and there's no reason why we shouldn't be able to model what they do in the system after what they do in the real world. This is a huge area where if you've ever had to have these conversations, it usually doesn't go well. Right. So let's talk about some of the things that we can do. I mentioned notification. With sockets, this is one of the easiest things to do, right? Because if something changes on the server, you simply broadcast it to your clients and say, hey, something changed. And I'll show you 3 different ways we can do that. But first, a demonstration. So I've got an app running. And remember when I said I do a lot of back-end programming and I'm not a UI guy? This is my evidence of that. But I've got an application here. Is the text too small? Make it bigger. Okay. And I'm not logged in, so I'm going to log in. And the extent of the security in this case is typing my name. Once I'm and by the way. Here, let me make it small again and do this. I did implement the obligatory chat. In case you do feel that this example is not complete without chat. Hi. Chat is the best. All right, so back to the actual demonstration. I've got this messages here, and yes, this could have been prettier, but this is going to work for us. I go back to home. So, and I've got this little button that's just going to generate notifications, right? So if you notice that the messages are ticking up as I click on that, and if I go in here, I see that I've started some reports. If I clear it, I don't have to clear it, but it'll just make it easier to see. As those reports are completing, they come back. And I know that the example itself doesn't blow you away. I wouldn't expect you to be, but let's look at what's happening in the code. So before I talk about the actual notification code, I want to give a little shout out to the RxJS extensions. So RxJS, who's used it? So I love it even without sockets, but it really expresses itself very well with the particular solution set that WebSockets brings. RxJS is started as the reactive X extensions for C# or for .NET, and it was a different paradigm on responding to things, right? So basically, what it says is you're going to be able to subscribe to things rather than iterate over a list. And as we push forward in this demonstration, you're going to see how that's really, really useful, right? Because when I show a list of things, I'm never done actually iterating over that list because the server can always send new things. But it's also useful just in simple event response, right? So in this case, I have this log in, log out events, and if you saw in the chat, it showed you which users were in the chat. If I were to log out, it would have sent the log out event, and I would have been able to respond to that by saying, hey, I'm going to remove that user from my list of users. There's a concept of a subject and an observable in RxJS, and a subject is simply, it is an observable, but you can also push things into it, so it's a little more versatile in this case when we want to say, okay, well, if I have this event that a user logs in, I'm going to add that user to the subject, which means that I can respond to it by subscribing to the observable. And that is, where did I put my little clicky thing? That's what we see here with subscribe, right? So subscribe is, basically you can subscribe to an observable and give it a callback method, and when that observable has something to add, you can respond to it. Now, what I'm not exactly sure of is why they have this confusing for each. So for each, for all extensive, but in all respects, except for a very few limited sets of problems, is basically the same thing as subscribe. From what I've read, and I can't really experimentally show that this is a really reasonable explanation, for each is really meant, and it makes sense by what it's called, to be iterating something that you know will end, right? But as I have here, and I have in another example in some future code I'm going to show you, you can use for each to do exactly what subscribe does. The drawback that I've been told is that it's not cancelable because it's based on promises. So if you are going to keep it going but you want to be able to cancel it, you should just use subscribe. My advice to you is just use subscribe. I can't really find a good use case to have to use for each. They both basically do the same thing, though. You would say, okay, well, every time there's something new, then do something, right? Okay, so let's talk about the actual, what's happening on the server here with Socket.io. There are 3 different ways to send events over your socket in Socket.io. One is, where did it go? Emit. So in this case, we're emitting on a particular socket, right? We get the user socket, and then we emit an event to that user. So this is a single client. When we emit on a particular socket, it goes to just that client. We can also emit on the io.sockets. And what that's going to do is it's going to emit that event to every single socket that's connected. And then the third one is broadcast, where we are going to go to the individual socket and we're going to broadcast. What that says is it's going to send it to all the other sockets. We don't care about hearing it on our own socket. In a little bit, I'll show you that we can further refine this using namespaces, but this is the basic 3 patterns for creating events on sockets on the server side. On the client side, this is basically how we bootstrap our socket. We say on connect, and this is, because you have to be able to account for the fact that your client may get disconnected and will reconnect automatically. One thing I didn't mention is that as much as I dislike polling, Socket.io and most other socket frameworks will gracefully downgrade to polling if it can't reestablish a socket, or if it's on a browser that doesn't support it, or if the server doesn't support it. But basically, when we connect, we're going to send logins so that the server knows that we're there. The reason that we do this on connect, even if we're already logged in, is that the server is going to recognize when we disconnect. So this just makes it a little easier. Outside of all the events that we care about, right here and right here, we're going to say, okay, well, when we receive those events from the server, do this thing, right? So when we get a token, save this token in local storage. When we get a notify, call this .notify.next. Yeah, here's an example of where I did both for each and subscribe, and they work the same. But where's I think this is the one where I have. Well, I'm going to feel like an idiot. I just put the slide in, and now I don't know why I put it in. I'll come back to it if I can't figure it out in 10 seconds. Oh, okay. So yeah. So this is back to when I was showing you the notifications. We're actually talking about the code, the example I showed you. So notification count and notifications right here. So if we go back to the fact that when we receive this notify event, we call this .notification.next, and that's a service that basically ends up calling calling these two subjects, right? So remember I told you about the subjects and the observables? It pushes messages into these subjects. In this case, it pushes an update to the count. In this case, it pushes the actual notification that got displayed in the notification list. And this is the actual push. So I had this in reverse order, and that's why it got a little confusing. So when we push the notification in, it pushes the notification count and the notifications. Okay, so streaming. And I'm not talking about media streaming, although you can do media streaming with WebSockets. I'm talking about streaming events. So, oops, here. Demo. When I go to support requests right here, I get support requests. That might seem, just somewhat pedestrian or elementary, but what's happening here is I actually tell the server, hey, can you give me all the support requests? And then it streams them back as they're available. The reason that is more useful is that the server may not be able to get all of them at one time. We don't have to implement paging to get this done, right? We can basically say, okay, well, you know what? I'm going to manage the paging on the client side. I'm going to take the ones that the server gives me. If we wanted to throttle it, if we wanted to say, well, just give me the first 10, and then when I want the next 10, I'll ask for it, we can actually do that by simply saying, start here, give me more, right? It's easier than what we would do in request response, but also it's the server sending them one at a time. When I click on one of these, what gets displayed down here is also coming back from the server. So I send an event that says, hey, find this thing, and the server finds it and sends it back. Now, I know that from the explanation, it doesn't sound that cool, but let's get into what's happening in the code. So when I clicked on one of those items, what I have is this get support request that gets called by the UI. And what you see here is I'm going to emit an event called find. Now, what you notice on this one, I'm passing it the ID, but I'm also passing it a callback, right? So if you look over here on find, it actually receives a function, and when it gets the thing, it calls the function with the DTO. Now keep in mind, these are two separate processes. This is just a little syntactic magic that Socket.io gives you, which says, okay, well, if we want this to behave like a request response, we can do this, right? We can pass a callback in. What Socket.io is doing is it is creating basically a nonce ID so that when this thing gets this, it actually is going to emit an event to this client with that ID, and the client knows to respond to it. So it's just kind of building that in for you. But it's nice because it makes it a little simpler, right? The second example I have, we don't do that because we have this next item. So in this case, when we call get, we don't give it a callback because we want basically to respond to this next item one at a time, right? So when I display the list of items here, if I just reload this page, when that list is loaded into that page, it's actually sent to the page one at a time. And you may be like, wow, no, but that's too chatty. Well, it is chatty, but there's a lot less overhead in sending data over a socket than there is in request response. So it's actually a good thing, not a bad thing. We're able to spread the load out on the server. We're able to not block nearly as much as we do on a request response. I mean, there's a lot of blocking on request response just in getting the data and then formatting it and then putting it all together and then sending it back. With the socket, we're able to, if we go back, simplify both our implementation and what's happening on the server, right? So all the server does is it says, hey, look, I got this get event. What I'm going to do is I'm going to get my items, and then I'm just going to iterate over them and emit them, right? On the client side, it's also very easy because we say, hey, look, if somebody requests an update, like, for example, when you load a page, I'm just going to emit the get event. Oh, and if there's another item, I'm going to display the item, right? So this works both if I do it through request update or, oops, or if the other user, oops, left, adds an item, right? So if you notice it here, I double clicked it, but if you notice, pretty much as soon as I added the item here, it showed up over here. And what's also interesting is when I click the add button, when it displays it in my own list, I don't code that into my UI. I simply tell the server I'm adding an item. The server sends the add item event or the next item event to both of these clients, right? So from a programming perspective, there's a lot less that you have to deal with when if you well, how many people have tried to deal with bubbling events between components in Angular? Yeah, was it fun? I mean, it wasn't as bad as it could be, right? But it's not that fun. Well, in this case, we don't even do that. We simply tell the server, hey, look, I'm adding an item, and the server says, hey, everybody that's on this particular namespace, there's a new item. So on that, let's see if we have the namespace piece next. I might have accidentally got rid of that one. So one thing to note is that when we get onto this page, here, let me just show it to you in the code. When we get onto this page, there is a namespace associated with it. Ooh, why do I have unsaved changes? So in support.js, and this is on the server, when I initialize this socket, I do io.of support. And what that says is, okay, well, this is kind of like a page. It looks like a route, but it's not necessarily a route, but it's a good way to be able to differentiate. On this particular socket, when I'm emitting events on this socket, it only goes to things that are in this namespace. So, you can avoid sort of spamming pages or clients that are not on this page by using namespaces in this case. On the client side, what that looks like is I'm losing people. Hopefully it's not that bad. Was it? Yeah, here it is. Okay. Connect support, right? So on a per page basis, in Angular, we're talking about on a per route basis, you can use namespaces to differentiate what, or to sort of filter down your clients. There also is a concept of rooms, and when I get to a different pattern that I'm going to show you, I'll talk about why I should have done it as rooms but didn't. It can be any string you want, but well, I guess I would say that the concept of a room is kind of like a channel. The concept of a namespace is kind of like a filter, right? Or I don't know, maybe it's channel and subchannel. But so whereas a a chat may be the namespace, the room would be the actual chat that you're in. Does that answer your question? Okay. Yeah, potentially. So there's another pattern that I'll show you around soft locks that is kind of like that, right? So if I had done it with rooms, which I should have, what it would say is, okay, well, support is the namespace, but the particular item that you're on is the room, right? So everybody who is on that particular support ticket would also be in that room and would be subscribed to those events, right? It doesn't go arbitrarily deep. So if you wanted more rooms, then if you wanted to go deeper, you would have to use like slashes or something in the rooms. But there's no cost necessarily to implementing rooms. Okay, and this is really just a lot of what I've already shown you, but it just kind of shows it in the order that it happens. So if I load the page, I request an update, and it sends the get. On the server side, it iterates through the items and calls next item. On the component TS TypeScript side, it responds to next item by adding the model. In adding the model, what it's really doing is it's just adding the model to the support request subject. And then the component, the list component, is subscribing to that, and it pushes into its own model, that model. And then on the client, all we have to do on the HTML is say let support request of support requests. There's no other code that we need. If we add another support request to this, if on the server I click new and another item's created, this handles it. So it's not just at the time you initially render it. If you ever add anything to support requests, it will continue to handle that for you. So I know it's like in what, three different places here, or 4 different places, but this is all the code required to handle that, right? So in the end, it ends up being better, and you don't have to again deal with the whole AJAX side of things. Record locks. So this is another place where we can have a real world benefit, right? We never have to talk about optimistic concurrency again. Demonstration. So record locks actually ends up being one of the easier things that we can do here. If we both are on this record, well, here, I don't even have to be on this record. If I click the little lock here, it shows on both screens that I have locked that record, right? In addition, if we're both in this record, notice I can't edit this at all. I can edit this. If I click the unlock button, on the other side, it unlocks immediately. And now I can edit it. So in addition, I don't know if you saw this, but when I click, it tells the other side who's locking it, right? So this is a record level lock. And it's pretty easy to implement, and it's very useful to users, right? This is what users have wanted and have had to give up because they moved to a webified world. They don't have to give it up anymore, and it really doesn't create a lot of work to implement it for them, so there's no reason to make them give it up. Here's the code for it. On the TypeScript side, basically when I click that lock, actually let me show you I don't have the HTML, so let me show you the HTML. Item HTML. So right here, and this is all the code that's on the HTML side. If it's locked, I show the unlock. I show the unlock button. If it's unlocked, I show the lock button. Right. And then on the component side, actually, I do think I have that code in here. Yeah, I do. Okay. On the component side, if I click lock, then I push the lock event into the the subject, and then I emit lock, right? And then this is the other little bit of it here. So I'm emitting the lock event on the server side. When I receive that lock, I do a little bit, but basically right here I emit to the namespace that record has been locked. Again, this is where I might have been able to use a channel, but in this case, we also want to display it on the list, so namespace makes sense. And then on the client side now, I'm responding to that by setting locked equals to true and saying who locked it, right? Everything else is really just taken care of by Angular for you. And if you noticed on that, I'm also doing a little bit extra. I'm checking to make sure that it's not my lock and changing the icons. Really don't like the placement of this podium. Sorry, I move around too much for, I feel like constrained back here. Soft locks. So here's where you can add value. So the users think they want record level locking. In a lot of cases, it's more useful for them to have field level locking. So let's do a demonstration of that. If we're both in the same record here, and on the left side I start typing, on the right side here, I can't edit that. If I wait a few seconds, it updates, right? So now I can. And now I can't edit it on this side. If I wait long enough, it'll update it. This allows you to be able to, I guess, collaborate. I mean, that's not really the value in it. I think the more the value is that a lot of times your records are too chunky to lock the whole thing, right? It gets in people's way. So if you have two people editing, and you see this now, like when you're editing in Word, and if you're using Google Docs to edit spreadsheets, it's not necessarily so you can be editing at the same time. It's just so that you don't get in each other's way if you are. So this one, I want to say that the code's simple, but it is a little more complicated. I had to build a wrapper, and I can't say that I necessarily did the best job here, but I did a job. And what the wrapper does is, at a field level, it emits that it's being edited. And when it's not being edited, it emits the release event. This debounce, it basically just says, hey, look, if I stop typing, wait 5,000 milliseconds, or basically 5 seconds, right? Then I have this little helper that says, hey, if it's locked, if the field is locked or the entity is locked, then you can't edit, right? So this is built around each one of the fields. I feel like there should be a better way to do this. There probably is, but this is what I ended up with. On the server side, there's a little more to it. And this is where I said I probably should have used a room, right? Because what I'm doing is I'm just concatenating this editing event to the ID of the entity and the field name, right? So I think the better way to do it would have been to emit editing and the field name on the room of the ID in the namespace, right? So it would have been namespace support room ID, and then event is editing and the field name. I didn't go that way. I kind of wish I did, but I didn't want to mess too much with it coming into this because I didn't want to have broken code. So, and then on the release event, it is simply going to make sure that it broadcasts to everybody who isn't the one that created the event that field has been released. And what it sends is the new value, the new field value. So when that field is released, all the clients are able to update the field with that value, and that's right here. So when I'm editing on the client, when somebody else is editing, I receive this event. I lock the field, and I set the name of the person who locked it. If they release it, I unlock it, but I also update the value. Now, on the actual HTML side, each one of the controls has to have these two things. This is where I felt like there should have been a better way to do it, but this is what I ended up with, right? So we're using two-way data binding to the value. So if you're not familiar with Angular, it has some kind of weird syntax around data binding, but this is two-way data binding, and then this is, I think, one-way data binding. So the reason we do two-way data binding here is that we also have to be able to update it if it's not locked, right? So the last one, and I don't have an example to show you here, just because there's this is quite a bit more comprehensive. But everything that I've talked to has led us up to this idea. And the reason I have those stairway to heaven here is that I always kind of think about this as like the pantheon of what we could accomplish if technology were to catch up with our ideas. I've always felt like, if you're not familiar with CQRS, it's command query response segregation. And the idea is that you have commands that tell the server to do something, and you have queries, which are completely separate from the command. Right, and then I've always felt that that's a good pattern, but the technology has never caught up with what we want to do here. And I still feel that we're not quite there yet, but we're getting closer with being able to do things asynchronously on the client, right? And I'll give you an example. The company that I work for right now is we do microservices in Service Fabric. So we have any number of services that really need to provide information to the user interface. Right now, we're using an anti-pattern where we funnel it all back through one front-end service, right? So that creates a lot of problems in a microservice world because that front-end service has to have some awareness of what's happening on all of the other services that are doing work, right? What would make more sense is if we have a front-end service that receives commands from the client and then broadcast those commands using a message bus, and then every service that cares about that event can subscribe to it and reply by emitting something on a socket, right? So you would have a socket service which is responsible for managing those, and you would be able to. The query is separate from the command. Even I want to see data is a command, right? So hey, show me this page. And that page actually needs data from 7 different services. Well, those 7 different services would asynchronously receive on separate nodes and separate instances those requests, and then as they're done with their data, they would send it back to the client in as real time as you could possibly get it. That pattern, if it's achievable, and I can't say it is achievable because although we are trying, we have a lot of legacy to overcome. If it's achievable, it presents a lot of interesting consequences both for CQRS and for microservices. So who here is working in like a true microservice environment? Yeah, so probably not, right? Because there are so many technological implications of doing it. I'm seeing them now, but we realize that in a microservice environment, it has to be event-driven, right? You can't. I mean, like, who went to Jimmy Bogart's talk? Yeah. So I mean, he nailed it when he said, "Hey, look, you can end up with 9-minute response times, right?" Because if you have 100 services and they're all calling each other using request response, that adds up. 150 milliseconds becomes minutes. So bringing it all together, if you are already in an application that is traditionally request response, it may be kind of hard to sort of weave this approach into it. If you're starting new, it's something to think about, right? I didn't necessarily want this to be a roadmap on well, go build an app that looks just like this. You can go to the example code. It's more just to kind of spark your imagination and get you thinking about, well, in a world where we have this available to us, how should we change our assumptions about user interfaces, right? I find myself continually frustrated with how we implement web pages. So I went a little fast. And I apologize about that, but hopefully you guys will have a lot of questions here. This is how you can get a hold of me. This is where you can find the code and the slides, and then this is just my blog. Thank you.